Thanks, Dan. Thanks for everybody being here. I made the mistake of putting geometry in the title, and I thought nobody was going to show up except for a couple of math people. So it's really nice, and there's not very much math content at all. It's the exploration of my online class. Hey, Gary. In the beginning, there was Sister Mary Catherine Brechting. She was the geometry teacher at Aquinas before I came here in the 98-99 school year. And one of the nice things we do at Aquinas is a new professor can have an upper-level class right out of the box, which I appreciate very much. I don't know how it is in other departments, but in math departments all over the world, the new guy gets the short end of the stick, usually 4 sections of whatever their entry-level math class is. Very brutal. When you got your PhD, you want to do some fun stuff, and now you got 4 sections of pre-algebra. It's kind of tough. So she gave me her geometry class, and very soon after that, the state of Michigan required a college geometry class for anybody seeking a high school math certificate, which is a very popular item. It's lost popularity recently, but the demand for the course went very high. So all of a sudden it became, from a once every 2 years upper level math course elective, it became a yearly offering plus alternate summers, and I was teaching all these sections. So I tried one book and had a good time, but I thought maybe there's more. And I tried another book and I had a good time, but I thought there was more. One of the things that's in all these college math courses is you have to look at the foundations of geometry, you have to look at hyperbolic geometry, you have to look at elliptic geometry. Those two with Euclidean geometry sort of form the big 3 in geometry at the college level. You have to look at these things. And one of the things that's difficult about elliptic and hyperbolic geometry is if you develop them from formulas, you have to have at least Calc 3, at least. So our geometry course has a Calculus 2 prerequisite. So we try and teach it in a way that we kind of skip these formulas a little bit and get to the good geometries. But one of the ways that you can reach these interesting geometries is by construction with a compass and straight edge, just regular old drawing compass like you might even remember from when you were in high school. So I got into this. I started to do compass and straight edge on the side and really liked it. Then there was a Math Monthly article by Chaim Goodman Strauss that showed how to do some hyperbolic constructions. And that got me all excited. Because if you want to be a good high school teacher, if you want to interview for a job and they throw something at you with compass and straight edge, you better be good with compass and straight edge. And you don't take that in most college geometry classes. It just doesn't come up. And then I thought, well, here's a way to get compass and straight edge into a good college geometry class. But we're still doing the content that we're supposed to do. So I thought that was a good idea. And it gives us a way to get to hyperbolic geometry and elliptic geometry without the formulas, and yet it's a perfectly legal mathematical way to get there. So I thought that was a good thing. And then Kathy Burgess got us a site license. Aquinas bought it for a thing called Geometers Sketchpad. Let me show you that real quick. A very interesting little animal. In Geometers Sketchpad, you can construct geometrical objects, and whatever properties you force them to have, those properties stay there. Now, this little gray guy here, we're going to look at this a little bit later. This little gray animal, it's a hyperbolic hexagon with all right angles. So it's a 6-figured polygon, but in hyperbolic geometry, the lines are bent. Or let's put it this way, they look bent to people with Euclidean vision. So those gray things up there look bent. They're actually straight in hyperbolic geometry. But you have 6 90-degree angles, which you could not have in Euclidean geometry. You can't have 6 angles all 90 degrees. If you remember from Euclidean geometry, you can get 4 90-degree angles in a polygon, but you can't have 5 or 6 or 7 or more. So anyway, so this is going to stand for a quick introduction to hyperbolic geometry, but it really is standing for, here's what happens with this sort of thing. I can move points around, and whatever I constructed, those properties are maintained. I can drag pieces around, but if they depend on other pieces, the figure doesn't change. I'm just moving the circle. One of these other guys moves something. Maybe it's this one. Yeah. Most of these points don't even have options. This one did. But this was built as a one-piece. This hexagon was built so that hardly anything changes. But anyway, you can make these things, and here's one really good thing. If you came to my talk I think it was 6 years ago in the lecture series, I had a little calculator hitched up to the computer cart, and it was black and white, and it was projected, and it was fuzzy. And what's nice about Sketchpad is it's in color, and the drawings do things. You can animate the drawings. You can do all sorts of fun stuff with them, and you'll see that later. So all this came together with, so the Sketchpad, we got the site license for that, so I started doing compass and straight edge with that. And then I picked up a Wednesday job at the Kent Intermediate School District teaching in their accelerated math program, and my supervisor, Mary Nell Baldwin's over here wearing a name tag, which is very nice of her. Mary Nell got me in there teaching, and in I think it was my third year there, I got to teach a geometry class. And I brought in as challenging stuff these hyperbolic and elliptical constructions that we were doing in my high school class, and these in my college class, and these high school kids just ate it up. They loved it. So that was something that made me feel like I was doing something that was useful. So there I was developing these ideas and getting some good ideas, and I even got one publication on what I was working on. I brought the magazine with me if you want to see it. It was in my tenure and promotions package, Hyperbolic Tourist article, where I gave some of my new ideas using the stuff that I was using in class. So what was nice was having other people look at this and realize, oh, this is actually new. So it's hard to find new things in math because they've been at it for thousands of years. So there's some stuff that's new, and it's accessible with this program. So I had this really dumb idea. The dumb idea was this. I'm going to make a game. I'm going to make a CD-ROM that's a hyperbolic game. It's called Hyperbolic Academy, and you go to Hyperbolic Academy and you enroll there, and as you gain expertise with hyperbolic geometry, you move up levels in this school, and gosh, doesn't this sound like fun? Oh, everybody's going to want to play this game. So I went to San Antonio's joint math conference in 2006, and I pitched my game to Key Press. They're the publishers of Geometers Sketchpad, the thing that made the little fancy drawing. So I pitched it to them, and they kind of liked it, sort of, until they said, so who would buy this? And I said, well, you want to be, a pretty solid geometry student, so maybe you'll sell like 12 a year. And they said, well, we'll talk about this later then, and they told me that it was nice, but thank you. I got a free dinner out of it. And but I thought that was a good idea. It was such a good idea. So then we're sitting around, and you know how Don Chafee is. He's always hitting people with a stick, saying do this, do that. And Don keeps saying you should have an online class, and Cindy Van Gelderen says you should have an online class, and people keep saying you should have an online class. And Kathy Burgess comes and says at a math department meeting, we should have an online class. So I thought, what about this geometry thing? Maybe we could make it as a class. So that's where everything started, was take the stuff that I'm working on and make it a class. So I got a sabbatical. I got a semester off last spring, and this is my sabbatical report as well as this talk. So I wrote this book. So let's take a look at this book. It's got this really nice picture from when they were building the second floor. They had this pipe cutting and threading machine. And it's got these really nice circles. There's some concentric circles here, and it's got this big, massive red thing here. So I thought that would make a good cover. So even though I'm not going to publish the book until I use it a few times. But this is my idea of a good cover for a course called Geometry by Construction. So I write this book. And let's see what's so good about this book. Well, you can go through the first section and get to some good material, and you page along. And I'm going to skip to page 11 and show you something good. I think that's the one I want next. Yep. So I'm going to go to page 11. Now, this book exists as a website at Aquinas. My students, some of them are here. There's Dave and Nate. Ember dropped, but she's still here. I don't know why. And Jen. So these three, Jen and Nate and Dave, just wave. So they're actually enduring this class. This is their textbook. And they can skip to page 11 anytime they want. Hurry up. There we go. So here's page 11. And here's what the drawings look like in this book. When you move stuff, so I've got a triangle here, and this little green circle is called an in circle. This is called an X circle. When I change the shape of the triangle, the circles stay as in circle and X circle. And one of the things we'll be looking at very soon in this section is where this little in circle is tangent to this side, and the X circle is tangent to this side. There's something we can do there. There's something interesting to be done there. And we're going to take a look at that in the course. But what's nice is we can see what that looks like for this kind of triangle. See, angle A here looks like it's close to 90. We can take a look at when we make the inside triangle look kind of like an isosceles triangle, like AB and BC look close to the same size. It looks like when that happens that the in circle and X circle are tangent to each other at the same place. Interesting, we can look through these various cases. That's what the drawings in the book do. The drawings in the book are meant to give the students a little guidance in complicated ideas, and you can't do it on paper. But you can take a complicated idea and get it to appear in the electronic version of the book, and then in the paragraphs around it tell them, take a look at this idea, take a look at that idea, play with this drawing. And then down below, here's how to find the circumcircle of a triangle. You have to find the meeting of the perpendicular bisectors. So the perpendicular bisectors are changing their position, and just like over here, they change their position, but they still form the center of that green circle as you change the triangle. Really nice stuff. They can change the blue triangle to be various shapes. I can ask them in the homework about the circumcircle for an isosceles right triangle or an equilateral triangle or some other weird triangle, and they can move this around until that triangle is approximately that shape, or make one themselves, and see what happens to the circumcircle or the center of the circumcircle as we play with that triangle. So I wrote the whole book like this. And it's not a very long book. It's only about 65 pages, but they're web pages. When I print it out, it comes out to be about 165 pages on paper. So it's long on paper, but as a website, it's not that bad. So you go to page 12 if you want to, and there's page 12, more stuff. Let me show you another page here. So we're kind of looking at what the course is like right now. Let's take a look at page 31. Why did I put down page 31? Let's see. In page 31, by the time we get there, we're starting hyperbolic geometry. So there's this big picture of the pipe cutter and threader in another position. And there's a link to, you can go to the Cornell Library. They have Charles Dodson is Lewis Carroll, same guy, different name. He wrote 2 volumes of Euclid and his modern rivals. They have them online. You can actually read it scanned. You can read the book online, in which he writes this whole book about, he was writing at the time when some mathematicians thought that you could have hyperbolic geometry, and a lot of mathematicians thought it was a waste of time. They were believers in the sort of thing like we run into here in undergraduate college. If it doesn't exist, why are we even talking about it? That you have this kind of attitude amongst mathematicians. You can't have hyperbolic geometry. Why are we even talking about it? So he wrote a whole book about what's wrong with these people talking about hyperbolic geometry, which is ironic because he's completely wasting his time. It turns out that hyperbolic geometry and Euclidean geometry have the same standing philosophically and logically, which is really strange. But they can go and look at his book if they want to. And here's hyperbolic geometry. You can have these curved lines. The whole geometry exists in this space, this yellow disk, or you can have diameters. So you can have curved lines or straight ones, but they have to be diameters. So that's what's going on with this geometry. So all sorts of stuff can happen, but the curved lines have to be a very special kind of circle. I'm not going to teach that to you here. But that's what's going on with this. So my book introduces these kind of things, and we go there. And let me show you on page 38 one of the things that's nice. Suppose you have a very complicated idea, and you want to have it in your book, of course. So here's a complicated idea. It is the yellow disk is the space. The red circles are hyperbolic lines, and they form 90-degree angles with each other. Remember that gray hexagon? These are that same kind of animal. Suppose I'm going to require my students to be able to construct this, whether in Sketchpad or Compass and Straight Edge, and it's a long construction. Well, let's see what this looks like in slow motion. So you can do this sort of thing. So we have the beginning. I have 2 of these hyperbolic lines given in the hyperbolic space. And the first step is you make these things called radical axes. They meet at this point where they meet. This point here where they meet is the center of the next circle that's going to be a hyperbolic line. And now here's the instructions on the next step, and we show that next step. And here's the instructions on the next step, and we show that next step. So what happens when I teach this class over and over all these years is I have to do this construction in my class 5 times. And then kids come to my office to see it 2 or 3 more times. What's great about this as an online class is they can go to this page and do this slow thing over and over until they kind of get it. And they can have, they can have this thing taking up half their screen, and they can have Sketchpad open on the other half of their screen, doing the construction. They get stuck. They go over here and hit a button, and it tells them what to do on the next step. It's almost as good as talking to me in person, less noisy and smelly, but maybe not as personable. But everything you need to know is there. So it's a handy way to have a book. So I'm writing this book, so I'm going to leave that up there. I've got this book written. By the time April rolls around, the book's pretty much done, and I signed up to go and teach some of this online geometry at Lamar University in April. They have a geometry course there. So I go and I got a mini grant, and then Lamar gave me $750. So I fly down there and I hang out there, and I'm supposed to link my course with an existing a college geometry class. And I have my web book, and I've got my ideas of what we're going to do in those 2 weeks. The professor has told me what they're working on, and I've said, well, let me take it from there and do this. And he said, great, here you go. So I have 4 class meetings, which I thought was a lot. So I'm not doing it online, but I'm pretending it's online with them. I want to see, is my material clear enough? So I'm bringing my website to them and using it in class and trying it out with them. And a really sad thing happened. Down there in Texas, there's this guy, he's dead now, a mathematician named R.L. Moore, and he developed this method called the Moore method, in which, and I'm not joking, here's what you do. First day of class, you give your students all the theorems and definitions that they need to start the course. And then you give them further theorems to prove. And that's the end of the first class. They have to go and prove these theorems. So the next class, the professor says, well, what have you got? Did anybody get that first theorem? And somebody says, well, I tried. Well, let's see what you got. And the student puts the theorem on the board. And then everybody cuts it down because it's probably wrong because it's only the second day of class. They point out why it's wrong. And the professor is not supposed to point out how to make it better. He just says why this is wrong. And then another student gets up and tries her problem, and everyone sits around and talks about why it's wrong. Unless it's right, and then they talk about why it's right, and everybody's happy because they got something. So one of the things that happens in the Moore method is if you just happen to get kids that just aren't on fire to do theorems and proofs all the time, nothing happens in the class. And the professor himself said to me, sometimes in these Moore method classes, you can go a whole month without a problem being done correctly in class. And then he paused and said, this is one of them. So I've got this class, and it was unbelievable. College geometry, these kids didn't even know what the angles of a triangle in Euclidean geometry add up to. They hadn't proved it yet. They didn't know they add up to 180. Did you see Jen giggle? Like, this is like not knowing where the intersection of Fuller and Fulton is, and you lived in Grand Rapids all your life. You got to know this. I mean, how are you going to get somewhere in a geometry class if you don't know this, So I thought that, this class, they're building prove all these things. They hadn't proved anything in a month. They didn't know anything. So I had to quick do the homina thing and go very slow and do a little bit of this and a little bit of that. And then as soon as that first class is over with, I go and change all the stuff that I was going to do with them to fit with their almost zero amount of geometry knowledge. And I was kind of bummed because it made my work at Lamar much less interesting than I expected it to be. I don't want to go up there and lay an egg. None of you want to go up there. You fly to another school and you lay a big stinky egg. Nobody wants to do that. And that's what I was doing. But as I'm flying home, I realized, oh my God, if you're going to have an online class and you're going to open it up to the world, you're going to have to prepare for kids that don't know the material. The Lamar kids on paper are in a class that I'm thinking, hey, it's like my class, and it's April, and they should be doing this stuff. On paper, they look fine to me. If you're going to do an online class and a student enrolls and you look at their transcript and they have all your prerequisites, they look good on paper, but they might not know anything about what you expect them to know for this class. So the first thing I did was I went back to the beginning of my book. I have this set of rules. Oh, come on. Hang on a sec. I'll get there. what's going on with this? This is the book, right? There we go. All right, so I had this set of rules. And the first thing I did was, now, for those of you who know math people, this is the part that you just want to kill math people. They'll come up to you and say, here's what we're starting with. And it's a list of theorems and definitions. It's not very long. Learn this and you're all set to start first day of class. Hey, this is great. Now who's going to sit down and read this? Who's going to read that? Maybe Galileo. Just nobody's going to sit and read this. So not only did I have this very boring set of things that they better know before class starts, but I don't have any examples. There's not even a picture until you get to the very end. And I realized that this is the kiss of death for these online kids that don't have anything. So I made examples linked up to the spot where they are. So here's the stuff that I just had listed. Here's examples with the answers. So there's questions and answers. It's still not beautiful or anything, but at least it's something. So I did that. I went back to that beginning section, and I went back and did, for any complicated ideas, I made support material. So we've got all this nice support material, and it explains stuff with pictures. And so I did all that, but that was after in April, so I'm in May now, writing all this stuff down. And then I'm going through the book and doing not just those long constructions with a step-by-step version. I'm trying to take all the stuff that I remember from teaching this class a bunch of times. What was I asked about in my office or in class over and over? I went and made material for those more clear, trying to anticipate the students' questions, trying to make it as clear as I could. So that's what I've got for that. So here we are with the book's looking pretty good. I've learned something about how to write the book, but now how are you going to have class? I go to math conferences, and I went to one where a guy from Ferris was talking about his geometry class. He had an online geometry class. First semester he teaches it. He had about 23 kids, and it was a nightmare. He was using email to communicate with the students. Now, this is a bad move. Look at Don Chavey. He did online classes. Email for an online class is the kiss of death. You may as well just go and just break both of your arms. It's going to be easier to say, hey, I can't type anymore. We're going to have to cancel it. It is such a waste of time because student A chimes in and says, problem 5, I can't figure out where to start. And you reply to student A. God help you if you don't save that reply as a text to send to somebody else, because you're going to have 7 other kids emailing you about the same question. You're going to answer the same question over and over and over. And it's so tedious to read these emails and reply. Read and reply. It's just tedious. I don't want to go there. So this guy from Ferris, he's giving this talk, and he's talking about how, some nights he's up until 2 or 3 in the morning answering these emails because the kids aren't doing their math until 1 o'clock in the morning. Because if you convert to student time, 1 o'clock in the morning is like 5 p.m. regular human time. They're up all night, and that's when they work. It's insane. So, he doesn't want, and of course they're waiting until, let's say there's going to be a test on Thursday. They're emailing him Wednesday at 1 a.m. And he wants them to pass because he wants this online class to work. So he's up at 1 a.m. like a maniac. Just is a complete disaster. So then the second semester that this course is offered, only 5 kids signed up. And then after that, he said, we're never going to offer it online ever again. So I'm thinking, I'm never going to teach an online class, not until they come up with something better. So enter Mary Nell Baldwin, who, did I introduce Mary Nell Baldwin? Okay. So Mary Nell Baldwin, she's in charge of the gifted and talented and professional development, or she's the consultant. I guess she's in charge of this at Kent ISD. She's also in charge of the Michigan Literacy Progress Profile. I work for her on Wednesdays with these kids, and last spring, when all this other junk's going on, she introduces us to a tech person who shows us a thing called a Wiki. And it was love at first sight. No, that's not it. Go away. Where is it? Where's my Wiki? Was that it? Oh, it is. Okay, this is my Wiki. Thank you. All right, so a Wiki is a brilliant idea. Very simple thing, and you can get them here at Aquinas for free. You just type in, how you type in campus when you want the intranet? Type in sites.aquinas.edu. Google, as part of our contract with Google, supplies us with free wikis. So you can have one yourself if you like this idea. Very easy and a beautiful idea. The idea is this. Each page can be edited by a member, and you invite the members, and they get a username and a password. And that means that when you go to a homework page, First you got to sign in. So I'm signed in. I go to a homework page. Let's go to page 5. Now what I'm doing with my class is I'm giving them, hello, please go there. Good. I'm giving them the homeworks that are in the book, same homeworks, only they're on this wiki. And what I want my students to do is, before the homework due date, which is listed on the front page of the wiki and the front page of the book, before the due date, they get to go to this page, click edit the page. They edit this page. The page turns into the same page except it's a document. I thought I locked this page. I guess I didn't. Didn't I lock page 5? I'm sure I did. I don't know why it's acting like I can edit it. But anyway, so what they do is they go for problem 1. So here's somebody who goes for problem 1. They make a drawing, and then they make a comment. And, this is me saying what's next. And then here's Nate. This is Nate. See how it's Nat? That's Nate sitting in the back there. He has made a contribution. And then I said something, and somebody said something, and you can see these other people. Here's Kyle Teeples. He's made a contribution, and then there's me writing something. This is at the stage where we're forgetting to sign our name. We've gotten much better at this. Jeff Moore chimes in. There's me a couple times, Megan Hearn. I'm looking for somebody else from class. There's Jen DeLongpre. She has made a picture and made a comment, and then I can make a comment. And everybody in the class can read this anytime they want, and they can chime in a comment. And then what's really beautiful is if they forget to, I'm going to cancel the save. Let's say somebody forgets to sign their name. There's a history button. I click the history button, and it shows me all the changes by date and time of when things happened. So here's a fun story. I got an email from one of my students. He says, hey, I was working on the wiki, and I made a correction. I saved it. I saw it on the screen. And then, later in the day, I went to that page to do something else, and my correction was gone. And I thought that was really bad because students aren't supposed to delete each other's stuff. So I went to the history page to see who deleted his stuff. And I go and I find Earl's line for his editing, and it shows what he typed in with a red line through it. So then I click to see who put the red line through, and it was me. And I feel so bad until I go back to the history page and I look and see that I was editing the same page at the exact same time. And what I probably did was and I kind of remember this happening, I was typing in the same place Earl was typing because I was going to comment on this drawing. And I was typing in, and I thought, this is snotty. I'm just going to delete it. And I didn't hit refresh or anything. Earl's text was on the page. I just didn't see it. And how you drag and click until a whole section is ready to be. I dragged and clicked my stuff right in the same place he happened to be writing. I hope this never happens again because it was 2:30 in the afternoon. Who expects a student to be online at that's like 4 in the morning regular person time? So there he just happened to be working. So I just hope it never happens again. But what was beautiful is this history button gives you a way to see who did what. I had another student who claimed that she had done a contribution to the page, and I checked it out, and the history button, what she had done was she had deleted the whole page and restored it, and that was what she was counting as her contribution. So I could write her a note and say, that doesn't count. You can't just delete everything and put it back and pretend that you did something. That doesn't matter. And then another thing that's nice is you have this discussion page. You can leave the homework page and complain. You can put something in there that is peripheral, and it's not interrupting the flow of this homework discussion. When I'm supposed to have locked down this page, I swear I did, the organizer, the wiki organizer, can lock down the page so that the other students can't change it, which I try to do whenever the due date for the homework's done. And then it still exists. They can still look at it, but they can't just go and change it anymore. So that's a handy thing. Oh, and from the tech guy, I learned where they got the word wiki from. In Hawaii, the little shuttle that goes from the airport to the hotels is called the Wiki. So it's this get there quick with a group of people. So that's where they grabbed the idea from. So at first I thought it was from Wikipedia, which always has the math wrong, so I don't just trust it. But it's maybe related to that, having this document that everybody can add to. And anyway, so this wiki's a gas. I can edit it from home. It's Sunday night. There's nothing going on. In case you hadn't noticed, all the TV shows suck. So there's nothing to do. If it's raining, I can go on the Wiki and just see what people are doing. And I just dig it. I think it's really fun because students they're chiming in. They're using the ability to put an image in there. They're making comments on other people's work, and they're being really polite. I don't have anybody saying anything horrible, which is great. And what I love about this is I can imagine, and I'm trying to do it like it's an online class. So far, very few kids from the class have met with me in person. Once in a while, just very few. But I still get the sense that the students who need the support are finding it by visiting the Wiki and hitting the book and visiting the Wiki and hitting the book. They're starting to see what's supposed to go on in this class, and I think it's a really good experience for all of us all the way around. I can see lots of ways to improve the next time I do this class. But for the first time out, for me to be third week of the school year and I'm not sensing a disaster on my first online class, that to me is really good, because usually it's a living nightmare when I hear of these things. It's usually just a complete catastrophe, and it's not happening like that. Let's take a look at, I want to show you Wiki page 7 real quick. There's something nice on there. So I go to page 7. And there's going to be a bunch more pages. I have homework for the whole semester already made up. We've got people. Now look at this. This is page 5 was the first homework page. I'm referring to the pages in the textbook. Page 7 is the second homework page. And look at the difference. Kids are using different color ink. We've got, there's still some drawings they're putting in. Look at this. This is from Dave, who's here today. Dave did a great thing. He created, this is an example of Menelaus' theorem, the Menelaus. He's got an example of Menelaus' theorem that he did with pencil and paper. It looks like 2 colors of pencil or 2 colors of ink, scanned it in, saved it as a JPEG, and put it on the Wiki, which is great. We get to see his example. He's got his calculations off to the side, and it's correct, but it's really nice to see. Now, the homework problem was create an example of Menelaus' theorem that you made up yourself, do the measurements, and put them in the formula and show that Menelaus' theorem actually works. So he's got the calculations that verify that, by golly, this Menelaus guy was pretty bright. And next one, somebody did one in Sketchpad. So here's one that was done in Sketchpad. Now, Nate, you had one. There's Nate's. Nate had one. Nate did one completely without a drawing. Just typed it in. All 3 of these perfectly acceptable examples of Menelaus' theorem, and completely different from each other. And any student in the class gets to see, oh, Nate sent one in and he didn't even make a drawing. But he made a drawing and just gave the measurements. Well, I guess that's okay. And all I did was write, how about a drawing to scale? Well, he could have shown it if he wanted to, but I can tell from his numbers it's probably right. And then here's the other 2. They did the exact thing. They gave me the example with the numbers and then show that the theorem works, that this particular product of ratios comes out to be 1. So look at my comment here. I'm just all excited. I'm loving this problem 5. We have one example with labels only, one hand-drawn example, and a Sketchpad model. Very nice. And then I sign my name. So I've got 22 kids in this class. Well, 21 now that I had a drop. I got 21 kids in this class. There's only 5 homework problems on these pages. Well, it's nice to have problems that can be done 3 different ways, or a bunch of different ways. All they're doing is making an example, so that everybody gets a chance to do their own thing. What's also nice is I can put a hard problem on there, and Dave starts it, and then Nate chimes in, and then Jen chimes in, and then Nate throws in something, then I make a comment, and 3 people later, we solved it. Like a class. It's like in class. I'm just loving how it's going. The potential is all there. One of the small hassles is I can put a Sketchpad drawing on here, but not a dynamic one. They won't accept that right now. They'll take a still picture as a JPEG, but they won't take a dynamic drawing, which is too bad. One of these days they'll make it a little bit better. All right, so what else is so great about this thing? Well, one of the things that's nice about this class is in this book I have 4 new results. Let me just show you one of them. Yes, go ahead, Don. Yeah, of course. Yeah, because you're already on the internet. You could link to a dynamic drawing somewhere. Yeah, you could link to the book. You could link to anything. So it's all right there. Let me just show you. Let me see. I got to find the right page number here. Hang on. It's going to be, I think it's going to be 40. Yep. So this is a result that I gave a talk on last May at Grand Valley. They had a little math conference. This is I've been snooping and snooping and snooping. I'm down to one last list to go through. It's it looks like a new result, and so I'll be writing this up. But it's one step away from stuff we do in the class. So one of the things I'm digging about this class is I'm pointing towards undergraduate research, that you can do new results in geometry here. We're right up to it. Here's new ideas, because compass and straight edge construction for hyperbolic geometry and elliptic geometry has been almost invisible in the literature. Very few people do it. Most of them are dead. So there's only a few people doing this sort of thing, and they aren't thinking about it from the point of view of what can we do that is close to the stuff that regular students could do. Math people don't think like that. Researchers don't think, well, what can we do that just anybody can do? They aren't looking for that. So there's fertile ground really close to this class. So I'm pointing the way. Another thing that I'm doing in the book is, if you look at the background color, I play with the background color when we go to something that's not strictly required for the class, but is interesting, a little digression. I changed the color of the background page, which is stupid, because when I went to make the book, I had to go through page by page and lose all the background color because I didn't want to hit print and you're wasting all this ink tinting all the pages. So I don't know if I would do that again, but it makes it look nice because you got a little color background. Anyway, so that's a really nice thing, pointing away towards undergraduate research. Any questions? I'm going to show you one more thing and then wind it up. So just in summary. We've got an online class here at Aquinas. It's a 433 class. It's an upper-level math course. It looks like the potential is there for it to be a pretty good class. And so what I'll be doing with this next is working on the book version to make it better from whatever happens during class, work on my Wiki skills a little bit to make them a little bit more solid, and then next time it comes up, we'll advertise it and see if we get anybody from California to take it, or from Texas or whatever. Because if you go and just Google online college geometry class, you're going to see that they're all those classes that exist are for high school teachers looking to get a teaching credential. The class is basically high school geometry warmed over, just over again. There's nothing like this out there right now. It's a really different little animal. And then one other thing happened that was fun when I was at Texas. I got my son Mitchell, who's foggily pictured right here. He flew down for a week. He had a week off during the time I was there. So he came down, and we went to the Big Thicket National Preserve, because the classes that I met with only met on Tuesday and Thursday. So I was free Monday, Wednesday, and Friday, and Saturday, and Sunday. So we went to the Big Thicket on weekdays. It's an amazing place. They have these rivers that this is East Texas, and the Thicket Preserve owns the land bordering these rivers, and then every once in a while they own a huge surge of forest and swamp, and then the river, and then another big piece of forest and swamp, and then there's other national forests and state forests and private hunting forests all around this stuff. So it's a really beautiful idea. It's like a big sponge, because this is southeast Texas. It's 30 miles from the coast. When Katrina came through and hit New Orleans, it hit Beaumont, Texas, and Kuntz, and all these other towns, and they didn't have the same damage because they had this enormous sponge in place. When the hurricane or tropical storm by then comes by and hits with all this rain, the rain has a place to go, and the houses don't all get washed away. So it's pretty neat. Anyway, it's full of all these cool animals. We caught a speckled king snake, which is like an amazing thing. I couldn't believe it. We saw a copperhead, didn't pick it up. I wanted to touch it, but my son Mitchell said, either way you lose, Dad, because it's going to bite you or Mom's going to kill you. So I had to leave it alone, but we took a picture. And this is a little geometrid moth caterpillar on a post pretending to be a twig, which I thought was really funny. Like if he was on a stick, it'd be perfect, but he's on a post. And a Texas rat snake. This is probably a broad-headed skink sticking his head out there. A hog-nosed snake doing his thing. We have these up here in Michigan. This is a rough earth snake. Boy, we had a time. We had a great time. Just a wonderful, best sabbatical I've ever had. Looking forward to the next one. Last chance for questions. Go ahead, Gary.
Tell me a little more about the Wiki business.
Oh, yeah. Wikis are free. You can get one at Aquinas. Greg Vetter's 2105, and he's the guy. But you could almost do it yourself. It's so easy. You type in sites.aquinas.edu. Let's see if I spelled it right. Not HTTP. Oh, it's still. This isn't it, is it? This is it. This is it. Give it a second. Yeah. How come this is not the page that I get in my office. This is really annoying. Oh, I have to log in maybe. Let's try that. I didn't, because I'm just doing this card. I didn't do the full deal. Come on, come on. All right, where's sites? There it is. There you go. Now work. Don't make me look like I don't want to lay a smelly egg. Let's go. Yeah. So when you start one, you're the organizer. You're the guy. You have to send out invites, and you tell them what your password's going to be or whatever it is. And boy, it's easy. Your front page, you dress it up the way you want. There's only a few sites within Aquinas right now. They look like it's all political science stuff. I'm going to snoop. Let's just see what it looks like. Oh, it's up. Looks like maybe it might be a student thing. But you see the edit page, and they have the other. See, mine's at wikispaces.com, so my front end's, my dashboard's a little bit different. But it's free, and it's huge. I mean, you can just load stuff on there like crazy. It's really quite fun. Yep, that's your history button. Date and time and the name of the person who made the changes all the way through. Even if they nuke the whole website, you click on the date where the website last existed and hit restore, and your website's back. Your page is back. So a kid can try and destroy your page in case you get some, let's say a math person who doesn't like you. They might go in there and just nuke the whole page. You just go in and restore it, and then you can go, as organizer, you can go up to that kid and remove that person's status as member, and then go change your password so they don't use it again, and then give everybody else the new word. And as long as Psycho Brain doesn't get a hold of it, they can't change your website. No.
Would it be something you could link from your Course Connect page for a course?
Yeah, because it's a website. It's really a website. Other people can look at it. Anybody. It exists as a website, but only members can edit. So a guest can look at your stuff. So you're still posting to the world. So you don't want to put the kiddie porn on there. That would be bad. I don't. Dan, you had a hand? Okay. All right. Yeah. I don't know who would use this, but for me, as soon as I saw this at the Kent ISD, it's like, oh my God, this is the perfect forum for my class. This is so great. And it was such a big relief that somebody had come up with something that I could use, because I didn't want to use Course Connect. I'd used it for a math class, and it was okay, but it was so busy. There's so much crap on the screen all the time, and you got making the links. You got to know what you're doing here. It's like it's so intuitive. An idiot like me could do it. I just had no idea. And I'm doing stuff. It made me feel good. But you got to learn a little bit, but it's not so bad. All right, anything else? That's 114. That's pretty good. Have a good day, everybody.